තාම කට්ටිය ජොයින් වෙන හින්දා අපි තව චුට්ටක් බලලා මේ පටන් ගමුනේ.
ඕකේ.
හරි.
හරි.
මේ මීටින් එකේ ඉන්න හැමෝම මේ තමන්ගේ නම හරි නම රීනේම් කරගත්තා නම් හොඳයි නේද? මේ නික්නේම් වලින් ඉන්නවට වැඩිය මේ කට්ටිය තම මේ රීනේම් කරන්න පුළුවන් නම උඩ ක්ලික් කරාම එනවා මේ රීනේම් කියලා. එතනින් ගිහිල්ලා මේ නික්නේම් වලින් ඉන්න කට්ටිය මේ තමන්ගේ නම දාගෙන රීනේම් කරගත්තා නම් හොඳයි නේ.
That is true. Hello. Hello.
Hello.
Hello.
Good morning, everyone. I hope that all of you can hear me.
Yes, Nangi.
Yes. Okay, so welcome to Eyes on AI episode 3, organized by the FOSS community of NSBM. So, first of all, let me warmly welcome our speaker for the session, Mrs. Achini Adhikari, who's a technical lead and a PhD research scholar at Research Centre for Data Analytics and Cognition of La Trobe University, Australia. And as the title of the session goes, everyone will be introduced to applied data science today. And so I hope that all of you will support our speaker to conduct the session quite interactively. And without further ado, I cordially invite Mrs. Achini Adhikari to conduct today's session. It's here to you, ma'am.
All right. Thank you so much for the lovely introduction and warm welcome. So welcome everyone to the session. So this is an introduction to applied data science. So I hope to broadly talk about what data science is, AI, machine learning, and some of the data analytics life cycle process. So I think we can start. So if you can't hear me, or if there's any issue with the internet connection, just let me know if I break in between. All right. So today we'll talk about positioning data science in the world of AI, and we'll talk about what data science really means, analytic spectrum, and data science lifecycle. So before we go in deep, just for me to know about the audience. So all of you are from computer science background, I believe, and you have programming skills. So what are your skills? Just you can let me know, a couple of people maybe in the chat. Anyone? So I guess you'll have an understanding, but this will be more like an introduction session. So we won't go into more technical details because that might be too much for you at this point. And I think there's a couple of other sessions lined up to discuss in deep about the technical models. Right? Okay. So we'll start our session. Okay, data engineering background, computer science. Yes, okay. Oh, that's good. So there can be students with some idea, and some can be new to this field as well. So this is broadly about data science, the introduction session. So I think that will be useful for all of you. Okay, to start with, AI is, so all of you have heard about AI, artificial intelligence. So artificial intelligence is defined as human intelligence exhibited by machines. So if we just broadly talk about intelligence, what is intelligence? So that is at a very high level, the ability to process information so that it can be used for decision making and future predictions. And when that intelligence is coming from biological beings as humans, we call that human intelligence. And when that intelligence is engineered or crafted, we call it artificial intelligence. So that is the intelligence that we try to give to machines. So that's AI is a very broad term, and it's a broad area as well. And this machine learning, data science, everything, we'll talk about how all these are connected together. So if you talk about AI and the spectrum of AI, so we are in this area here, right? So artificial narrow intelligence is at the bottom layer. So this does not mean that it's low intelligence, right? It's very narrow. That means these AI applications are trained to conduct a very specific task. So it can be how to recognize an license plate in a car, how to classify different images of animals, a chatbot. So those tasks are very specific. And what we mean by AGI, artificial general intelligence, is that it's when AI is able to mimic human behaviors. So we can't say if it's a human or a machine. So it's that much similar. It's a long way to achieve this, right? So there's lots of research being done to achieve AGI, to make machines that are equal in intelligence as humans, but that's a long way to go still. And artificial superintelligence is what we actually see in movies, right? So it's when AI takes over and surpasses human intelligence. So in this spectrum, AI, practical applications, we are still in this part, and it's a long way even to achieve AGI. So this is about AI and an idea about what AI is. And then we have heard about all these terms, AI, machine learning, data science, deep learning, big data. All these are buzzwords. You must have heard these things. But let's see how these are connected together. Okay? So AI is broadly how we can reproduce or mimic human intellectual activities. So there we have the expert systems, robotics, human interfaces here. And one way of doing that is learning rules and patterns hidden in data. That's what we call machine learning. So AI is the broader umbrella term, and there we have machine learning as a component. Machine learning models, there are diverse amount of machine learning models, starting with simple regressions, decision trees, and neural networks. So neural network is one of the most used and most prominent machine learning models. What neural networks are is, so those are inspired by human brain. Right? So you know how our brains start to recognize things when we are small, when we are born, and how our brains are trained throughout the course of time. So that process is duplicated in computational neural networks, and it's simulate brain activity. So that's how we train these models. And deep learning is a component of neural networks where we have multi-layer neural networks. So neural networks can be very simple ones with one layer, and when it has multi-layers, it's deep learning. And deep learning is actually associated with lots of applications because it can handle large volumes of data. Basically, big data are mostly driven by deep learning models. So these things, it's good to know where each component fits. Then it's easy for you to understand what are the differences between these terms. So when we take data science, it overlaps with all these applications because data science is understanding and making sense of data. So even in AI and machine learning applications, we use data, we model, we build a model, and we get outcomes. But we need to interpret these data, right, to actually use them in a business decision-making process. So that is where data science comes in. And data science has many phases in the life cycle, which we will talk about later. So machine learning is about predicting, basically. So what we do in machine learning is, we will the machine learning models will take some data, and it will automatically learn the patterns of these data. And when new data comes in, it has not seen before, it can predict the outputs of the new data. So based on the trained model. So for example, say we are training a model to identify an image of a dog, right? So data would be different images of different dogs, and the model will learn what are the features of a dog, right? And when we present the model with a new image, it can identify if it's a dog or not based on the trained or acquired knowledge. So this is what machine learning is about, basically. And once we build such model, it's easy for you to train that model to identify another object. So that's the beauty of it. So these machine learning models can be reused for different purposes. So let's see an example of how we can differentiate between traditional programming and machine learning programs. So in a say our use case is we want to identify if an email is a spam or not, right? So how would we do this in programming sense? So a basic crude way would be we'll identify a set of keywords that often appear in spam emails, and we'll specifically look for those things, right? So here, as the example shows, so if the email contains the term lottery, then we mark it as spam. Similarly, we can look for other words like promotions, advertisements, and such keywords, and we can use rules to say if these words are in the email body, then mark it as spam, right? But that's limited, right? That's limited to the keywords and in our program. A machine learning program, what we can do is we can give a set of spam emails and let the model, machine learning model, learn by itself. So the machine learning will learn what are the patterns of data. So what words often appear together in the spam automatically. And when a new email comes in, it will classify it as a spam or not, right? And more data that we feed in for the machine learning program, more examples of spam emails that we give, the accuracy will be much better because it has a lot to learn from. So this is a simple comparison of traditional rule-based programming versus machine learning programs. Okay, so let me know if I'm going too fast or too slow, so we can, if you have any questions, then we can talk about those as well. So let's see what is data science. So data science is the mastery of all above and more. So we need to be thorough about the data science, data science life cycle and data science process, starting from the raw data until we get the business insights. So knowing machine learning, deep learning is important. It's extremely important. But if we can't interpret the results or the outcomes that we gain from machine learning, then there's no use, right? So that's why the data science life cycle covers the end-to-end process of analytics, and we need to be thorough about the entire process. Okay, so applied data science. So this is transformation of data into insights that inform decisions. Because the data analytics, it should be relevant. Otherwise, it won't be any use, right? So any business case, any machine learning model, it should serve a purpose. So that's why we need interpretable results. So first, this is the data science process. So we have data that get fed into analytics techniques. So machine learning, deep learning, those are tools for this. And then as outcomes, we generate insights that are the requirement for the business domain. And from there, we make decisions, right? So to make it more clear, this is an example. So data, all of you must be using, phones to track how many steps you walk and how long you run, right? These are using phone or wearable devices and trackers. A lot of people use these data. So data would be input. So in here, number of steps, it can be all other things as well. That get converted into information by having an interpretable format. So this will show how many steps you walked every day. And then from there, we get the insights. So this part needs deep exploration. We need to spend some time on that to identify insights. Right? So insight would be at this time, today I have walked this many steps, but it's below the average, right? So that would be the insight, and the action would be you have to walk more tomorrow, right? So it's a very simple example starting from data, information, how we gain the insights, and how we translate that to an action. Okay, so let's talk about the analytics spectrum. So this one here, you can see this spectrum. There's 4 types of analytics, starting from descriptive analytics, which is at the low end of the spectrum, saying what happened. Diagnostic analytics is why did it happen. Predictive analytics is what will happen. Prescriptive analytics is how can we make it happen. So let me take an example, right? So say we are going to a doctor, and in this stage, the doctor will ask, what are your symptoms? What happened? So we focus more on information at this stage. And then once we have all the information, we can make a diagnose, and we call it diagnostic analytics. Why did it happen? So we provide insight on the causes, why that happened, and what were the reasons for these events. And then the next stage is predictive analytics. So there we make predictions. We say, okay, so you have these symptoms, and this seems to be the illness. And if you don't treat it, you can have these side effects. So those are predictive analytics, predicting what the other illnesses would be, right? So in analytics terms, we call it predictive analytics, where we are able to forecast what is likely to happen. Then the last stage is prescriptive analytics, right? So we know what is going to happen, and to make that happen or to prevent that, what are the actions that we need to take? So that is prescriptive analytics. So it's actually providing foresight and the knowledge to generate the desired outcomes. So if you can see this axis, right? Difficulty and value, prescriptive analysis and predictive analytics, they are in the higher end of the spectrum. That means they are high, they provide very valuable insights, but it's difficult to gain these insights as well. That is where we need to conduct our data analytics and data science lifecycle phases. Okay, so how we are going to do it? So this is the analytics lifecycle. So we talked about broadly AI, machine learning, and data analytics spectrum and the flow. So we know these things, but how are we going to do this practically, right? So applied data science actually refers to how we can use this in real life applications, because as I mentioned earlier, it's not all theory. We need to be practical and get some interpretable results out of it as well. So analytics lifecycle, it has several steps. First, we have to identify and formulate the problem. So what is the problem? What is the business case? And what are we going to solve? So that we need to properly identify our business problem. Then we need to prepare data. We need to collect data and identify data sources, mainly. From where are we going to get data? So that data preparation part. And then data exploration. So that is, once you collect the data, before you build any models, you need to investigate the data. You need to see if there's any errors in the data, any abnormalities in the data. So that happens in this phase where we explore the data. And then the next stage is we need to transform and select. So there will be different processing steps for this data, because we need to we can't just use the data as it is to build the machine learning models. So that data processing part happens in this phase, and then we build models. So here we are working with machine learning and deep learning and models. So this is this step. So we need to build not only one model, we need to build a couple of models and see which one is the best. So that comparison happens here. Once you build the model, you need to validate it. We can't just deploy the first model that we create. We need to create multiple models and test it and see what is the validation and select the best model. And once we select the best model, we need to deploy it in different ways. So deploy it in a way that it can be consumed by the stakeholders. So it can be a deployed solution or a visualization. So we need to deploy that and then evaluate and monitor results continuously, right? Because we need to keep an eye on the performance of the model. And if there's any issue here, then we have to repeat these steps or maybe revise some of these steps. So mostly we will have to again look at the data and see if our pre-processing is properly done. We need to check our model. So that's why it's a life cycle and it has these phases. So I hope you have a good understanding about the overview of data science analytics lifecycle now. So next part, what we'll do is we'll take one by one and we'll talk about each step with the examples. So I'll try to give examples as much as possible, and that will be easy for you to understand as well. Okay. Right. So we are going to start here, right? So first one is identify and problem formulation. So I will just briefly mention 4 case studies in 4 areas. So that will give you an understanding on what and how we can identify the business problem. So analytics in retail. So simply take a supermarket, right? Simply take a supermarket, and there are lots of they have lots of data. They have the customers' buying patterns, and they have the transaction data. They have their warehouse stock data, and from this huge amounts of data, and what we can do about it, right? So one thing is you can use customers' buying patterns to predict product recommendations, right? So we can see that, okay, a person who buys these items together, they are more likely to purchase this item as well. So we might promote that to these people. And even I think more close examples for you would be eBay, Amazon, Netflix. They all use this our previous data to provide recommendations, right? So okay, because you watched these movies, you might be interested in this movie, right? You must have seen all these ads popping up on Facebook whenever you browse for something, and you get all the related things in advertisement on the next day, right? Not even the next day, next hour, probably. So like this, so this they use the customers' purchase data to predict product recommendations and also to anticipate future products. And another very useful use case for retail is using the demand and supply information. We have to predict the stock management in warehouses. Say if you take a supermarket, what will happen if you put more products on the shelves and people don't buy, right? That will go into waste. But and if you put low stocks, then people will come and buy this. There's no products to purchase. They'll be disappointed, right? So you need to have the optimal level of products on the supermarkets to reduce wastage and to prevent customer dissatisfaction. So these are the things that we can do using warehouse data. You can predict the stock demand beforehand, so you can have the optimal stocks ready. Here also it shows different objectives, so you can better analyze your customers and provide a customized service to your customers based on the retail data. And another case study would be in HR. So employee data also has, that's a huge amount of data that any organization has. So those can be used to improve employee experience and performance, and automating tasks, and even visualizing, so you can identify productivity peaks in employees. And another important use case is some large organizations actually use employee data to predict the churn rate. So churn is that if a person is going to leave the company or not. So they anticipate based on their performance data and everything, if a person is going to leave the company or not. So this churn prediction is one of the important use cases in HR industry. If we take healthcare, that's another massive industry with massive amount of data, patient records, and in large hospitals, they use these sensors where they collect patients' biological data, and also these wearable devices, IoT sensors, which continuously monitor your heart rate, pressure, blood pressure, all these. Those also are very valuable sources of data. And using this, they can actually use predictive analytics to anticipate future hospitalizations, and if a person is getting more sick, and even they can use it for optimized resource allocation. So lots of use cases in healthcare. I have only mentioned a couple of things here. So you can get an idea, right? What are these use cases where we can use analytics? And again, in another example would be manufacturing, where we anticipate if there are going to be any faults in the systems, and therefore you can prepare well for any emergencies like that. So it's actually called a predictive maintenance, and it's useful for you to optimize time, money, and labor. Right? So all these things are made possible actually with the new devices that bring in more data. So that is where big data comes into play. So these IoT devices, sensors, social media data. So all these high volume of data, those have made predictive analytics possible in these domains. Okay. So apart from those case studies, there's advanced AI use cases, object recognition, visual analytics using images and videos, speech recognition, sound detection, natural language processing, sentiment and emotion detection. So my research is mostly focused on this part, sentiment and emotion detection from textual data. So we use social media data to identify people's emotions, and language translations, restoration and transformation. You must have heard about deep fake and all these novel deep learning technologies that is able to do these things. Smart chatbots, which can not just rule-based chatbots, but smart chatbots that can actually understand what you are saying like this Google Home, Siri, and all these novel technologies, autonomous vehicles, and there's many more, right? Okay, so so now we know what is how we can identify this problem, and now it comes to data preparation. So here we need to understand business data. We have to find the relevant data sources, right? So if we take the supermarket example again, if we want to predict the stocks in the supermarket, we need to find relevant data. So we need the transaction data and maybe even weather data, right? So based on the weather, there can be certain products can be more, should be more available. If it's very sunny, we need more cool drinks, ice cream. So things like that, right? So weather data can be an external data source. Likewise, we need to identify what are our data sources, and we need to acquire those data. And there's big data, small data, and we need to think about the privacy constraints as well if we are using data. So environment scan for complementary data is what I meant from weather data. So complementary data sets that can be used to improve our predictions. So that is what we do in data preparation. So it's the same thing what I mentioned. Data sources can reside in different locations, and they can be in different forms as well. So we need to gather data, extract, and acquire in this data in this stage. One of the important things, as I mentioned, is the privacy concerns and ethics, especially when you consider social media data or customers' data. We need to be mindful about the ethical aspect of it. We should not take any identifying information, should be anonymous. So big data, a little bit about big data. So big data has these 4 properties. Probably you have heard about it. So volume, as the name suggests, the scale of data with the new technologies and devices. There's millions and billions of data generated at a second in the world, right? So volume is a characteristic of big data. And the other one is velocity. So if you take social media or traffic data, within a second, there's billions of data generated. Okay? So we need to consider these attributes whenever we design a data analytics solution. We need to be mindful about the volume, the velocity of data. And the other one is variety. Variety is different forms of data. So big data can appear in many forms, right? It can be numbers, it can be images, it can be text, it can be videos. So different forms of data, and we need to handle different forms of data differently. And veracity. So veracity is uncertainty of data. So this we have to be sure about of data. So although we collect, say, millions of data, how accurate are they, right? So that's the main concern in when we using big data. We have to see how valid our data set is as well. So these are the properties of big data. Just for your knowledge, it's good to know about these properties of data. So types of data, I broadly mentioned there are that different types of data. If you take this chart here, you can see all data very at a higher level. It can be structured or unstructured. Right? Structured data are mostly categorical and numerical. Right? So structured data essentially can be you can represent them in a tabular form, right? In a table. So categorical data has nominal, ordinal, binomial types. Numeric data has discrete, continuous. So here there are some examples on different data types. So quickly to mention that, so discrete data is the data that you can count. So it can be age or the number of rooms in a house, so things like that. Continuous data are things that you measure. So it's length, weight, temperature, those things. Categorical data is nominal data and ordinal. So nominal means these are always a couple of categories. So if it's gender, if it's male or female, if it's a color, blue, green, red. So this a separate category for that. Ordinal data is there's a rank to it. So always, usually, sometimes. So these are ranked. You must have seen these in forms. These are called ordinal data. And when you take unstructured data, there's text, images, audio, video, data streams. All these are unstructured. And before we do anything with the data, we need to process them using different techniques. So whatever data that is, it needs to be transformed into structured form before we use it. All right, so let's have a look at a data set, right? So when we are using in data analytics, so it will have these terms will be appearing all over in this predictive analytics. So we have a set of input data that we use to train the model, and target is what we are going to predict, right? So if it's a house price, so price is the target and features are the inputs, and cases are the number of observations. So this is an example. So I'll explain using this so it's more meaningful for you. Target, say our use case is to predict the house price, right? So target is the price in dollars here, and inputs are the features of that house. So we have a number of bedrooms, number of garages, number of bathrooms, land size, crime rate in the area, and if there are schools nearby or not, right? So all these things impact the price of a house, right? So we call these features, and we call them inputs, we call them predictors, different terms, it's the same thing. Let's call them input variables here. So using these data, we are going to predict the price. Right? So those are the terms that you should be familiar with, and the cases are the number of observations. If you have 1,000 data of 1,000 houses, then you have input variables here, and price would be the target variable. Hope that is clear. So we'll quickly move to data exploration. We have a couple of steps to discuss as well. So data exploration, we usually spend a lot of time in this phase, right? Before we do any modeling, we need to identify what our data tells us. Right? So what is data exploration, and what are the features of the data? So there's a couple of specific questions you can ask at this stage. Are these variables relevant? So we might be getting data from different sources, a lot of data sets, but we have to think, are these variables actually relevant? So that's a decision that we have to make in this process. And we have to see if the data is complete. In most cases, in practical real life data sets, all these issues will be there. There will be errors, there will be abnormalities in data. So we need to see if the data is complete, and are there any outliers, extreme values, and are there any missing values? So missing values where we don't have data in certain columns. If so, what are we going to do about it? So all those are decisions that we have to make at this stage. And do we need to process the data if it's not in a structured form? And is there any bias in the data set? So is my data set balanced? So these are a couple of charts that we did in one of the projects at the center. So even at this stage, you can get some insights. Right? So using data exploration, you can see that in the summer, there's more energy consumption compared to the rest of the year. So these things actually give out some idea about the data set, and it's our job to pull out those insights. So these are different ways you can plot data to visualize, because then that will give you a better understanding about the data. Right? So you need to torture the data until they confess, right? So you have to get pull out as much as possible from these data at this stage. And then transform and select. So once we identify different patterns in data, we need to move to the transform and select stage, where we prepare it for the machine learning models. So these are 5 things that we usually do in this phase. So we need to handle missing values if there are any missing values. So are we going to keep them, or are we going to remove them, or are we going to modify them? Even for outliers. So how are we going to handle any abnormalities in our data? Normalizing and rescaling, handling categorical variables, variable selection. So I'll talk about this in the next few slides. Okay, so in our example, let's see in our supermarket stock prediction example. So we are taking data from transactions, and we are taking weather data as well. Say you don't have the weather data for one day, what would you do? Right? So it's a couple of things. So one of the mostly used techniques is to replace them with previous data. So we will take the last 2 days weather data, take the average, and fill in the missing data with the average. So that's one way. Or if it's a very small percentage of data, so you have 100,000 records, and there's 2 or 3 records with missing values. So you can choose to remove them. And if not, even depending on the data type, you can even data. So that will be also one of the features in the dataset. And when it comes to handling outliers, so I won't go much in detail to these techniques, because it's important for you to know what are the steps. And if you take the techniques, there are different techniques that can do this missing value imputation and outlier removing. So just it's good to have an understanding about things that we have to do, and the techniques you can select based on the business problem. So outliers can be easily identified by plotting the data. So you can see if you take a normal distribution, if there are any extreme values, those are what we call outliers. And outliers can sometimes denote errors in the data as well. So for example, if a person has put age 150 or -1, so these, these are wrong data. Okay? So based on the business case, you can decide to keep the outliers or remove them. Normalizing and scaling is another thing, because numerical data can appear in different ranges. So when you build the machine learning models, you need to scale it to one range. There's different techniques to do that, like min-max normalization and taking all the data between 0 to 1. So these things we don't have to discuss more, because this is the introduction session. But it's good to know and be aware about these techniques in the data transformation process. And this is, I would say, one of the most important steps in our data analytics life cycle. That's dimension reduction. So dimensions are the number of input variables that we have. So in our house, so here, this is the dimensionality of our data set, right? So these are the variables, these are the dimensions. So here we have only 6 input variables, right? So what if we have like 1,000 columns, 1,000 input variables? So that can actually impact the accuracy of the predictive models, because we are using a lot of data, and sometimes those data can be not relevant as well, and that can also cause high computational power, and that can cause problems. So if we have, in a case where we have a lot of input variables, we need to condense that. We need to make it a smaller data set by using dimensional reduction techniques. So in that way, we end up with only a few variables which are really important. Because if you take any data set, there will be variables which are not relevant, right? So for example, if in the supermarket data set, you have the customer's transaction data, that is, this customer brought 3 units of this product. So we don't need the customer's ID or the customer's name. So all those things are also present in the data sets. So you need to remove those unwanted columns. And there can be even variables which are very similar in nature. So in that case, we can choose to pick one of the similar ones. So that's what we call variable clustering. We group similar variables together and we pick one from each group. So that is also a way to reduce the number of input variables. And this is very important. We can select variables based on our domain knowledge. If we think that this variable is not important at all, we can choose to remove it. That's why I told earlier. So if you are doing data science, you need to have an analytical mindset. You need to always question why this happens, and do we need this part? Do we need this variable? So exploration actually takes up a lot of time than modeling in a practical sense. And you can use data summaries and correlation analysis to identify similar or highly correlated variables and pick only one from that. And there's the automated dimension reduction techniques as PCAs. You don't have to worry too much about these things, but it's the most important thing to know is no matter how many data points you have, data sets you have, before building any model, you need to pick the most relevant input variables. Otherwise, the model will not perform well. And when it comes to this point, so we need to prepare our data set now to model, right? So build the prediction model. Then we have to, so now at this point, we have our cleaned data set. We need to split this data set into different parts. First, we need to allocate large portion of data as the training data set. So it should be more than half of the data. Usually we take 60 to 70% of the data as the training data set. So this is the sample of data that we use to train the model, right? And from the data set, we set aside a data sample called the validation data set. So whenever we train the model, we use the validation data set and see how the model performs. If the validation data set gives a good accuracy, then it's good. If not, we again retrain the model. So either you can retrain the model, or we can go back to the data preparation steps and see if my data is correct. and if my data transformation steps are correct. So you can spend more time on the data exploration part, and again train the models until this validation accuracy is increased. So we have a large portion of data to train the model, and we use a set of new data to see how to validate the model if our model is good. And only after we validate the model, we use it to test, that is to test it on new data. Right? So in this step, we need to split the data set into 3 parts. Okay, so now we have done the data exploration, we have split our data set, and we are at this point, we are going to build the machine learning model. So I'll explain this a little bit more using an example, because I think because it's a new area for you and because it's an introduction session, I think using examples will be more useful rather than just talking about different techniques. So this is what happens in predictive modeling. We have a data set. So this is our training data. If you have a look at this, so X, Y, Z are our input variables, and our target variable is we are going to predict if this is going to be accepted or rejected, right? So this is the class is what we are going to predict. So we have a data set with the input variables and the class label, and we feed that to the machine learning algorithm. So the machine learning algorithm, it can be a regression model, it can be a neural network, it can be a decision tree, it can be a deep learning model, it can be anything here. So it will learn, okay, what are the features of accepted differentiate between the two classes, right? So now we used, this is our training data set, and we have built this model. So when it comes to predicting, we have a new data item, right? So we have X, Y, Z information, but we don't know the class. So we need to predict if this person is going to be accepted or rejected. So we use the model here. So we give this data item as the input to the model. So the model knows, okay, if we have these values for X, Y, Z, class is going to be this, right? So it will give the outcome as accepted, and it will say, I am sure 88%, right? So 88% it will be accepted. So this is how a prediction will work. The model will always give the outcome. So if it's like a 0.5, then we know the prediction model is not that good, right? It's not good at all because it gives a 50-50 chance. So if it's less than 50, that means it's terrible. You have to redo the model again, right? So we train the model and we use the trained model in prediction. So that's what happens in predictive analytics, basically. So I mentioned that when it comes to machine learning, there are different models. There's regression models, decision trees, neural networks. You must have heard or maybe not familiar with those as well. So you don't have to worry about that, because machine learning broadly can be supervised learning, unsupervised, and reinforcement learning. So I'll just simply explain what this means, so it's good for your knowledge as well. So supervised learning is where we have a training data set for the model, right? So we have a data set with labels. So labels, this is what we call the label, right? Label of the data. So in supervised machine learning, we have a data set with labels. So we can simply give that data set to a machine learning model, and the model can learn the difference between the different labels and predict what's the outcome, right? So supervised machine learning is can be broadly classification and regression. Classification is where we predict a category, and regression is where we predict a continuous value as the target variable. I'll show that in the next slide. And unsupervised learning is where we don't have a label, right? So it's just a data set. We don't have a category, or we don't have a label. In that case, say it's just a customer data. So we have customer ABC and we have their transaction data. Okay? We don't have any label to say if this is a, say, important customer or not, say, like that. So in that's what we call the unsupervised learning. Then the machine learning model must learn from an unlabeled data set. So we can't actually provide a direction to say this is these are the labels. It has to learn on its own. So they are mostly use dimensional reduction and clustering. So this is an example. So if we give a data set based on the similar characteristics of the data, it can group the similar people together. Right? So there's no label, but it will just point out that, okay, these groups are similar. It's important in customer profiling. Unsupervised learning is mostly used in those exercises. And reinforcement learning is separate to these two. It's learning by trial and error. So we let the model run, and when it performs well, we reward it, and based on that rewards, it will learn to optimize the accuracy. So this is a spectrum of machine learning, and there's some use cases as well where we use each of these models. So based on your use case and based on your data, we need to pick what is the model that you're going to use. Okay, so these are different types of machine learning models. So neural networks, deep learning, even statistical models, Markov models, decision trees, and all of these have this is the prediction accuracy and the explainability. You can see when it comes to explainability, highest is the most simple models, because you can actually show this is why this label was selected. So explainability is we don't have to talk much about it, but broadly it's when you make a decision, you have to be able to say why you made the decision. So in our earlier example, that model predicted that the customer will be accepted with a 88% probability, right? So we should be able to trace back and see what lead to that decision. So that's what we call model explainability. That's a different area, so you don't have to worry about that here. So this is what I mentioned in supervised machine learning, regression and classification, because this is what we will be using for predictive models, because we are going to predict something, right? So regression is when we are going to predict a continuous value as the target, like house price, temperature, energy consumption. We are always predicting a number, right? So in this example, we are going to predict the temperature, right? But if you are going to predict a category, then we use classification, right? So temperature is regression, but if you want to say if it's going to be cold or hot, then we use classification. So even some of the examples are churn prediction, if the person is going to leave the company or not. Sentiment analysis. So you can get a social media post, say online hotel review, and see if it's a positive review or a negative review. So these are classification examples. Okay. There are a couple of questions. I'll talk about all the questions at the end of the presentation. Then we can even have it as a discussion. All right. So we build the model, and after that, we are going to validate it. So we need to see, we have built a couple of models. What is the best model? So validation also has a couple of steps. So evaluating the predictive analytics model is an essential part of any data analytics project, right? Because if you are going to the your stakeholders, you need to present the model with a certain amount of certainty, right? And because of that, once you build the model, you need to thoroughly test it and using different metrics and pick the best model. And also, sometimes a model can be too good to be true, right? If your predictive model is, if you say it's 99% accurate, well, that means there's something going on, right? Usually we are happy. First, we are happy. Okay, we got 99% accuracy. Our model is the best. But when we dig deeper, if it's really good, like 99, 98 point accuracy, we need to double check our data, double check our variable selection methods to see if we have not made a mistake. Because sometimes we can, by mistake or because of the issues in data, we can overfit the model. That is, we are using a very specific data set, and that is more related to the target variable. Then the accuracy will be very high because it's been trained on that particular data set, and it's very biased. And what will happen is when we have that type of a very good model, when new data comes in, it can fail because it has seen only certain type of data. It's very biased. When another different data comes in, then the accuracy can be low. So evaluation is important. So we need to have reasonable accuracy. If we have 98 point accuracy with all the good steps, then that's great. But if not, we have to always explore and see if our model is valid. So you don't have to worry about these things. It's good if you have heard about these things. That's why I added this here. So when we, how we measure the model evaluation is, so in regression, the output is a continuous variable, right? So for example, house price. Then, sorry, we have these types of errors that we can generate to see what is the accuracy rate. So if house price, this root mean squared error is 10,000, that means there's a plus or minus 10,000 prediction error. So if a house is say 50,000, then there's 10,000 plus or minus error. So that's a bad model, right? So things like this will give an idea about how good your model is, what is the prediction error, what is the accuracy rate, so we can proceed ahead. And if it's a classification, like we are predicting a category, then we can, these are the metrics that we will use: classification accuracy, confusion metrics, which is a very famous one, F1 score, and area under curve metrics. So here what we do is, in the confusion metrics is something like this. So we have the actual value, positive, negative, and we have the predictive value, positive, negative. So if the actual value is also positive and the classifier is also predicted as positive, this is the correct prediction, right? And this is a wrong prediction. So using the number of correct and incorrect predictions, we can get a accuracy measure to see how good is our model. Okay, so once we have the once we validated our model, we pick the best one. So we usually you should usually create several models, not just one regression model. You can change different settings, change different input variables and build another model. You can change the way you transform the data in one model and use another technique to build another model. So you have you can try out a couple of things and then pick the best one, right? So that's what we actually meant by experiment with machine learning models. You can change these data exploration transformation methods and build several models to pick the best one. So once we have a good model with a reasonable accuracy, we need to deploy it so it is consumable by stakeholders. So who are going to use this data? I think there's a question also asking that who are the persons engaging with analysis circle. So this actually this different stakeholders. First, we are starting with here, right? So what is the business problem? Who is getting the benefit? If it's an organization, the objective is to reduce cost, or for that supermarket example, our business case is to predict the stocks for next week. And then the stakeholders are warehouse managers, even customers, right? And once we have the data, this will be done by the data science teams. And once we deploy, the insights will be consumed by the stakeholders in the organization. Okay. I'll talk more about this part. There's a separate slide on creating insights. So deployment, you can deploy the solution to provide predictions, recommendations. And when it comes to technologies, you can simply make a REST API to get the data and output the predictions. You can use Docker, AWS, Azure, Google Cloud Platform to deploy. And the visualizations are very powerful as well in this data science lifecycle. You can use HTML dashboard, and Microsoft Power BI is a very interactive tool. It's free if you want to try it out. The Power BI desktop version is free to download. You can simply get an Excel Excel and import it to the into Power BI and create visualizations. It's very powerful in that way. Tableau is a commercial product, again, very interactive visualizations which will actually show the outcomes. And when deploying, there's a couple of things that we need to think about as well. So basically, we have to think, are we going to actually use a machine learning model? Does that serve our purpose? Because sometimes if it's a small organization and it's a small data set, sometimes using a rule-based programming would work, right? Having machine learning and everything would be a different or would be more costly. So those are considerations when you want to proceed with the machine learning models. And sometimes you can build hybrid rule-based and machine learning systems. So that's a combination of machine learning and rule-based. So again, based on the cost and the business case. Again, we have to understand the computational cost when deploying. Production environment, are we going to continuously train this model with new data, or are we going to use the same model? And then again, as I mentioned, how explainable our model is. So for example, if we say that using a machine learning model, if we tell a person your application is rejected, we should be able to tell why, right? So that's what we call model explainability. So all these considerations are important when you decide to deploy the model. And then the last stage is evaluate and monitor results. So the deployed model should be continuously monitoring to provide optimal decision making. Right? So we need to keep an eye on the outcomes and the performance of machine learning models to see where it fails. And if there's a sudden anomaly detected, what caused it. So we need to keep an eye on the deployed model. It's a continuous process. We can't just build a model, deploy it, and be done with it. We have to monitor it, and if there are any changes, we need to go back to the data set and follow those steps, because that's why it's a cycle. It's not one flow. It's an iterative process. We need to continuously monitor. So this is an example of a Power BI dashboard. So these dashboards, real-time dashboards, are very useful to monitor what's happening, and you can actually identify if as well. Okay, so so this is our life cycle. What the different phases of the life cycle, starting from the problem up to evaluating the results. I will quickly talk a little bit about deep learning, because it is a trending field in machine learning, and there's lots of research being done, and maybe for your university projects and all, also you must be using or thinking to use deep learning technologies. So deep learning is really important when it comes to big data, because when the data grows by millions and billions, traditional machine learning models often fail, because it can't handle that much of data, or it won't be able to perform better. So in that case, deep learning is very powerful. So if you see this one here, so traditional machine learning models saturates very early. If you have very low amount of data, say you have 1,000 records of data, then the best idea is to use traditional machine learning, because with the small amount of data, traditional machine learning models like regression, decision trees, they can actually perform well. But if you take deep learning, deep learning need more data to saturate. So if you have only 100 or 500 records, using deep learning is not a good idea, because you won't get good results like you would get in traditional machine learning, right? So you can see the hype here. When the data grows exponentially, right? There's a lot of data, then deep learning will perform way better than traditional machine learning, right? So that's why I said it all depends on the business case, the data that where you have to use the model that you're going to use for prediction. So deep learning has new brain-inspired learning algorithms. That's the cutting-edge technology, and performance even to train, that is very computationally intensive. So you have to think about all those things as well. So these are different type of deep neural networks. Just for you to listen to these terms. So deep neural networks, where we have more hidden layers, so there's more feature extraction happening. Recurrent, so this is good for tabular data, so data that can be used in a structured form like a table. And there's recurrent neural network known as RNNs, which are good for sequence data, like text data or stock market time data, which fluctuate with time. So for data with a sequence, these are used. And these convolution neural networks are used for data types such as images and videos. Right? This is just for you to know about these different things. Okay, so this is a nice tweet. So what can or does machine learning do? So machine learning or deep learning, it don't create or collect information. It compresses information. Right? So it takes a large number of data samples, compresses out the noise, and identify what are the important features to do the necessary work. So that is what machine learning models basically do. So these are just 3 things that we can check. So can I predict stock market price fluctuation using machine learning? What do you think? Because there are things that you can do and with machine learning, and there are things that are not possible as well. So stock market price fluctuation, yes, right? So we can give previous stock market data and predict what is going to happen. Can I predict lottery winning numbers using machine learning? It's difficult, right? It's no, because it's random. We don't know. Yesterday we got these numbers, but we don't know today we can get those numbers or not, right? Yes, yeah. So we can't do that using machine learning. Can I predict if a person is going to have a heart attack? So that's a tricky one. What do you think? So you can, but you need to have the proper data, right? It's if you just have the say age, weight, like basic data, it won't be accurate. But if you have the pressure, the blood pressure, the diameter of the veins, and everything to the minute, maybe based on the quality and the accuracy of the data, you can predict if there's going to be a fluctuation in the heart rate. Right? So, so you can see that it all depends on what data you have available, because that directly impact our model. Okay, so I won't take much time. It's the last one. So once we follow our data science life cycle, the last point is we need to get actionable insights, right? Because without actionable insights, it's not useful at all, right? So in mostly in companies, what's being really offered is an analytic solution, not just or just information, right? But we need to focus more on insights. And so we say actionable insights are the missing link between data and business value. So we have data. When it's in an interpretable and understanding form, we call it information. And information should provide insights, right? What is really happening. So actionable insights, there are key attributes of an actionable insight. So it should be aligned with business goals and strategic initiatives. Otherwise, it's not useful, right? It should be consumable, and it should contain context. So we should have supporting information, right? So we are saying in our supermarket example, if you say we need to stock these products more in the coming week, you have to justify and say why. Otherwise, it won't have any value. So it needs to have context and supporting information. It should be relevant and it should be timely. So you have to present the insights at the right time to the right person at the right setting. So outdated information is not useful. And the insights should be specific and complete. It should be novel. There should be something new. We are using and investing all this time on the data analytics life cycle to bring out something new. And the stakeholders should be able to understand it. It should be clear. So this is these are the key attributes of an actionable insight. So in summary, so since this is an introduction to applied data science, I tried to give you an understanding about what are the data analytics. So we talked about broadly AI, and then the analytics spectrum, and then the data analytics life cycle, and we went through each phase to see what are the activities done at each phase. And we talked about the importance of actionable insights. So this entire process is important. I hope that gave you an overall idea about what data science is. So in summary, the most important thing is the process. Right? So imagine that you're preparing a meal, right? So you're making something. So you have the ingredients, right? In our case, that's the data, right? And then you have the tools. You have knives, you have a blender, you have an oven, you have a microwave. So all these tools. So in our case, tools, those are the machine learning, deep learning models, right? And so you use these tools to prepare a meal, right? So that meal can be consumed, and most importantly, that should be tasty, right? You should be able to eat it, right? So that's the outcome. So that's the actionable insight. So no matter if you have the right ingredients and the right tools, if you can't eat it, then there's no point, right? So likewise, you need to have the right data, you need to have the right tools, machine learning models, and you have to only then you can get the correct output. So it's important to know about machine learning, deep learning, and all these computational models, right? It's very important, but it's not enough. We need to follow the entire process, and as a student that you are learning about data science, you should be thorough with the entire process, and you should be able to handle it from end to end. And because that is how you will get an idea about the entire process. So even if you work only with data, right? So I saw a question as that data engineer only talk about data preparation, exploration, transformation. That's right. But it's good for you to know the entire process, right? Because even say if we don't know the business case, and if we don't have any idea about the outcome that we want to get, we don't know how to prepare the data, right? How to explore the data. If we have what we need in our head, then it's easy, or it's more meaningful for us to do the data preparation, exploration, and transformation, right? So it's like you already have what meal you are going to prepare, so you can pick the right ingredients and right tools, right? So it's important to know about the outcome and the entire process. Okay, so basically you need to know the entire process in data science, because each step is crucial. And I hope that I was able to give you a broader view about the data science life cycle, and potentially like if make you feel interested about pursuing data science. Okay, so thank you very much for listening in. Happy coding. If you have any questions, if you need more information, you can email me anytime. So I will respond when I can. Okay, so I'll wind up my session. So I hope I didn't take too much of your time. So it's a introduction session, so you can get some ideas, and now you know these things, you can search a little bit more, read more, and get a deeper understanding about certain aspects. Okay, thank you. Any questions? Okay, so data engineer and data scientist. Okay, that's a good question. So data engineers, as you said, true. So data engineers mostly work with data preparation, exploration, transformation, you need to work with databases, handling different data. So that is usable for building models, right? So data scientists will take the modified data and they will focus more on the building the predictive models. But even though roles are, categorized like that, as I said, it's more important to know the overall picture, what's happening, because even you can follow the entire circle by yourself. You can practice, right? But when it comes to large organizations, there are separate divisions, as you said, to engineer for data engineering, and for building the model, there's another team, and to evaluate and interpret, there's another team, right? So that's how it actually works in large organizations. So different teams have different tasks. It's not only one person doing the same thing. But when it comes together, each team, they all have the same objective, right? So if it's to reduce, to predict the stocks in the warehouse, we know, even the data engineer knows, okay, this is the data, our objective is this. So when you have that in mind, it's easy to follow the steps. So yes, so there's different, when it comes to the industry, there are different job roles in organization to do this specific task. Okay, so I'm so glad that you enjoyed the session, and I hope I was able to give you some ideas about data science. It's an interesting field, and it's actually a trending field as well, in terms of even industry projects and everything. So it's a good time to get into data science.
So thank you very much, Mrs. Chini, for joining us today, all the way from Australia, and sparing time from your busy schedule. And your participation meant a lot to us, and the session today was very valuable, insightful, and educational as well. So thank you again so much. And
Okay,
so
no
before
problem.
concluding this, I would like to thank all the FOSS NSBM volunteers who worked hard to bring forth today's session, and everybody else who joined us today from NSBM and other universities as well. And you can see that I've put a link for the feedback form in the chat. And I hope that you'll be able to fill it, as your feedback is what helps us to keep improving and enables us to bring forth more valuable sessions and programs. And we will be back with Eyes on AI episode 4 next month. And while looking forward to it, stay safe, everyone, and have a great day.